Okay, so we have just come up with that the sine has the input of the angle swept counterclockwise from the 3 o'clock position, or the angle swept by the ladybug. The output of the sine function is represented by this red bar here. It's the vertical distance above the horizontal diameter. The key is that that output is in radius lengths. And by making it in radius lengths, we can apply sine theta to any circle, whether the radius is 2 millimeters or 100 miles. We can easily apply it to any circle. So our radius is 2.6. So what function could output the bug's vertical distance in feet? Anyone get it? What would it be? 2.6 times sine theta. You see? What function would output your location above the horizontal on the Ferris wheel in feet? What would you do? 90 times sine of theta. Okay? So if the radius is r feet, or radius has a length of r. Right. R units. Then our function, call it h now, r sine theta. If the radius is anything besides 1, so r, and if it's 1, it's sine theta, but r anything else besides 1. Now, it works if it's 1, but the point is it's trivial then. So when you have any radius of any circle, to get that vertical height in the units of whatever the radius is measured in, you just measure r times sine theta. Okay, does it make sense? Anybody have a question? Can I pull it all off the screen? Okay, so similarly, then we looked at the harder one, which was tracking horizontal distance. Why is that harder? Because we're tracking horizontal distance on the vertical axis on the right? So this is going to represent now horizontal distance. So what does the horizontal distance start at? 2.6, or 1 in radius length. So this could be 2.6 feet. We could say it's 2.6 feet, or 1 radius length. Either way. And then what happens in the first quarter circle, in feet, the bug's horizontal distance goes from what to what? 2.6 to 0. So that's what that blue graph is showing. The horizontal distance starts at the furthest place over to the right and then goes down to 0. And then, so coordinates of this point would be angle, pi over 2, 0, whether it's feet or radius lengths, right? Next quarter circle, the horizontal distance goes from 0 to negative 2.6. That's what that blue graph is showing. That's going to the left to negative 2.6. So this could be this horizontal distance could be negative 2.6, meaning to the left, or negative 1 radius length. Next quarter of the circle, it's going to go from negative 2.6 to 0. That's down at the bottom. At what angle? Overshot it. Come on, stop right there. Yep, so now it's at the bottom, but in terms of its horizontal distance, what's its horizontal distance? 0. So you got to see that. It's not negative 1. Negative 1's vertical distance. The horizontal distance is 0. It's right on the vertical diameter. And then finally, in the last quarter circle, it goes from 0 to 2.6 or 1, right? So either way, 2.6 radius lengths, back to this point here. 2.6 radius lengths, or so 2.6 feet, or 1.6 radius lengths. So many of you now quickly pick up what function this is. Cosine. Cosine of theta. I want you now to write out completely what is the input into the cosine and what's the output. So write out all the details. Practice. So angle is not sufficient. So what angle? And then, horizontal distance is not sufficient. What horizontal distance measured in what? Okay? So you write out this input and output of the cosine. Okay, so the input is?
Angle swept counterclockwise.
It's the same angle as before. Swept counterclockwise from 3 o'clock position in radians. Okay, if you were to change your calculator and set it onto degrees, then it would be wanting degrees. Okay, we know radians is the most convenient because it ties into arc length so nicely. But if you changed your calculator to degrees, and you hit cosine, it's expecting degrees here. That doesn't phase us, right? Okay, what's the output of the cosine? Horizontal distance.
To the right of the vertical diameter.
Right of the vertical diameter.
Starting at 3 in radius length.
Well, it doesn't have a start. The horizontal distance doesn't have a starting point. The angle does.
Oh, okay.
So, but horizontal distance right of vertical diameter measured in
Radius length.
radius lengths, which lets us easily convert to any circle of any radius length. Okay, so these are two foundational functions for tracking position on any circle. Tracking the position of a point on any circle. These are the two foundational functions. So let's go back. Oh, I closed it out. Let's see. So take a look at this now. This is what we're talking about. So can you see what's representing the vertical distance from the horizontal diameter? Can you see that? And can you see what's representing the horizontal distance from the vertical diameter? Okay. This is really the same as something else that you're very familiar with. These two values. Let me just stop it here. What is it really the same as? All this vertical distance and horizontal distance is simply what? What is the horizontal distance from the vertical diameter? What is that? X. And what is the vertical distance from the horizontal diameter? It's Y. So if the coordinates of this bug, that's what we wanted, are X and Y, then what are they in terms of these functions that we're writing? What would the X coordinate be? Cosine theta. Where's theta? Theta, right now, theta is like this, right? There's our theta. So input theta, the cosine is the x-coordinate, and the y is, sine theta is the y-coordinate. Okay? What about on the Ferris wheel? What would your, in feet, what would your x and y coordinates on the Ferris wheel be in feet? Remember what the radius was? 90 feet. So if we wanted the coordinates in terms of feet, how would we change this? What would we do?
90 times.
Would it be 90 times cosine theta? And 90 times sine theta. You see? Any circle, piece of cake, the fan, in feet. Any x, y coordinate that you want on the fan. How would you write it? 2.6 cosine theta. 2.6 sine theta.
So regular cosine theta and sine theta give you radius length?
Yeah, so this then, what is that giving us? What are those, what is the measurements then of x and y in terms of? Radius lengths, which you can apply to any circle. So you can call off on the Ferris wheel. You can say, I am 0.6 radius lengths above the vertical diameter right now. You know, or I could say I am 54 feet. So if you get to some angle where you're at 0.6 of a radius length, then you'd be 54 feet up. Sorry, over. Up would be sine, right? Up would be sine. Okay, does it make sense? Okay, so let's look at a new example here. So, just open up a new screen. Okay, so here's a circle. And I got it, if this is the unit circle, so I got it in radius lengths. So let's say we're talking about a clock, okay? A really big clock. So how large is the, well, clocks don't run counterclockwise though, so that's not a great example. So we're skiing in a big circle. Okay? So this is, I've got this from the book, I didn't think of that. So we're skiing in a circle.
That is so boring.
You got something better? I'm all ears. Whatever you want.
On a track, a circular track.
Oh, you want to run around track? Oh, awesome. I love it. Okay. We're going to run around a track. I don't know, not too many tracks are circular, but run around a circular track. Beautiful. Okay.
First circular track I'll ever see.
Okay, what's the radius of the circle track?
One radius. Like one
Well,
radius.
all circles have a radius of one radius length, but this one, say, 100 what?
Meters.
Let's do something a little more not so nice. How about 85 meters? That's a big circle. Okay, so I'm going to run 100 meters. I'm going to start at my spot here. We know this is our starting spot. I'm going to run 100 meters. I don't know where that's going to put me. It's going to put me somewhere.
Just past one.
I'm going to run 100 meters. I want to know the coordinates of the point in radius lengths and in meters. Okay? No calculators. We're going to set this up as an expression. Okay? No calculators. So, what would I need first? If I want to find coordinates, we know the coordinates are going to be, in general, they're going to be what? How are we going to get those coordinates? Using what? Sine and cosine, okay? So, cosine and sine in general, okay? So, in order to use cosine and sine, what do we need? Angle is the input. Okay, so I ran 100 meters. What angle did I run through?
100 divided by 85.
He wants 100 divided by 85. Right, so the angle is going to be 100, and we're just going to leave it as 100 over 85. Just leave it that way. Because we know radians is number of radius lengths. So what is my x-coordinate in radius lengths? What's my x-coordinate in radius lengths?
100 divided by 85 times
Uh-oh.
85. Sorry,
cosine of
So first of all, how am I going to get x-coordinate on the circle? That's my horizontal distance, right? Horizontal distance to the right of the vertical diameter. What is that? Cosine. Cosine of 100 divided by 85. Okay. What will my y-coordinate be? Sine of
100 divided by 85.
Okay, so let's, and now, these x and y coordinates, are they, what are they measured in?
Radius length.
Radius lengths. So let's just do this much. So in your calculator, make sure it's on radians. If you change it to degrees, change it back to radians. Find the x and y coordinates in radius lengths, which is what we just did. I hope you're right. Is x negative? I hope you're right. I don't think it is.
It's not.
It's not. Okay.
0.38.
All right. So what is it? 0.384.
384
We'll do 3 decimal places. Okay.
and 0.923.
So now let's get our arc length better. We didn't. We just thought we knew it was more than 1. So where's 0.384? Right about here. Okay. Where's 0.923? Up here. So that was really 100 meters. Is it okay that we missed the first time?
Of course.
Sure. So that's really our 100-meter trip there, from here to here. Okay? And we got the coordinates in radius lengths. Now give me the coordinates in meters. As an expression. So set up an expression. So here's the coordinates of the red point in radius lengths. What would the coordinates be in as expressions now, as expressions, because that's what you're going to have to do. What would it be? So what would the x-coordinate be in meters?
100 over 85 times.
Nope.
Oh, 100.
Nope. What will it be?
Oh, 85 times cosine.
What do we multiply by cosine? The radius. 85 cosine of 100 over 85 is our number of radians. Y-coordinate in meters? 85 times.
Sine 100 over.
Okay, so find those and let's see if it makes sense. So find those on your calculator. So something significantly but a little bit less than half of 85 and then almost 85, right? So what's the x-coordinate? 32.7?
Bless you.
78.5. Which makes sense because we're not quite halfway in terms of horizontal distance, but we're almost to the top of the circle, almost at 1 full radius length in meters. This is crucial to understand right here. Everything that's going on there. There's a lot going on. We built it up slowly. You really need to understand all that's going on there. Have a great weekend.
Oh, it's gonna be a great week.
Yes, we do. Yes. We do have class next Wednesday. And we'll see you Wednesday. We do have class.
Let's not say we did.
Yeah. Homework's due on Wednesday. Homework's due.
You should give another part. Because you know how many will be skipping.